Hi there, Mr. Sutton here with the IM313 Part 2 homework solutions on elimination method. For this problem, I'm trying to solve this system of equations using elimination. So at some point I've got to add equations together. First thing I'll check is to see if these are both in standard form. These are both in ax plus by equals c form, so that's good. Next thing I need to do is figure out if I add these together the way they are, will anything cancel? Doesn't look like it will. We don't have opposite-like terms in either of these. But what I can do, there's a few ways you can do this. If you wanted to get rid of the x's, you're going to have to multiply each equation by a different number to get something that 6 and 8 both go into. Probably 24 is your best bet. So you could multiply this equation by, say, 4 and this other equation by -3. And that would let you cancel out the x's. It's going to be much easier, though, to cancel the y's. Because if I just multiply this first equation by 2, that'll give me 12x minus 2y equals 10. And 2y and minus 2y are going to cancel out. So that's just kind of a one-step cancellation, much easier than trying to get rid of the x's. So we cancel those two y's when we add these equations together. We've got 20x on the left side, and on the right side that's going to be 20. So then dividing by 20 we get x equals 1. And now we just have to plug that into an equation to get the y value. So I'll plug it in over to this equation here. So 6 times 1 minus y equals 5. So basically 6 minus y equals 5. Subtracting 6 from both sides, I end up with -1 on the right side. And then dividing both sides by -1, we get y equals 1. So we've got 1, comma 1 for our final answer. To solve this equation using elimination, I have to check to make sure these equations are both in ax plus by equals c form. And it looks like they are, so I don't have to rearrange anything for that reason. I do need to make sure, though, that when I add equations together, something's going to cancel out. And I see that nothing is going to cancel right now, so that's a bit of an issue. So I have to figure out next, do I want to try canceling out the x's or the y's? And the question that I'm going to ask to help me decide that is, will I have an easier time finding a number that 3 and 4 both go into, or a number that 7 and 6 both go into? I'm going to go with the x's. If I multiply this second equation here by 3, that'll give me a 12x. And if I multiply this first equation by a -4 down the road, that'll give me a -12x. So that's what I'm going to do for this one. But I could have also multiplied this first equation by 6 and this other equation by 7, and that would have helped me cancel out the y's. So just pick a direction and go with it. This one we're going to have 12x plus 18y equals -30. And if I multiply this other equation now by -4, because I want to get the x's to cancel, that's going to be -12x, which is why we did that, plus 28y equals, and this is a little bit tricky, -4 times -19, that's positive 76. Now if I add those equations together, my x's cancel, so I only have one variable left over. 18y and 28y is going to be 46y. And then -30 and 76 is conveniently just 46. So then we get y equals 1. And if I plug 1 back in for y in this equation right here, I can now solve for x. So 3x minus 7 times 1, which is really just 7. And then if we add 7 to both sides, that's going to be -12. So divide by 3, we get x equals -4. And then my final answer, we have the point -4, comma 1. On this problem, I'm trying to solve this system of equations using the elimination method. So at some point, I'm going to have to add these equations together. Now, first thing I'm going to check to see is if these are both in standard form. And these are both in ax plus by equals c form, so that's good. Next thing, if I add these equations together right away, will anything cancel out? The x's will not cancel, and neither will the y's. So I'm going to have to multiply one or both equations by something that gives me opposite-like terms. So the next question is, do I want to get rid of x or y? What's going to be the easiest to get rid of? And this is one of those kind of half a dozen of one, six of the other. I'm going to get rid of the y's, though. I look at 10y and 12y, and I think I can pretty quickly come up with a number that those both go into. So those are both divisible into 60. 60 is the smallest common multiple, although you could use 120 as well. It doesn't really matter. So in order to make this, let's see here, which one do I want to do first? I'll do this one first. I'm going to multiply this equation here by 5. That'll give me positive 60. And just kind of thinking ahead, if I multiply this other equation here by negative 6, that's going to give me negative 60. And then positive 60 and negative 60 will cancel out. So let's put that in action. Multiply by 5 for this equation, so I have to multiply everything by 5. That's going to be 45x plus 60y equals, this will be 105. And now I have to multiply this other equation by negative 6 because I want to get negative 60y to cancel with the positive 60y. So multiplying by negative 6 for this equation, that's negative 72x minus 60y, that's what we really wanted out of all this, equals negative 24. Now if I add these two equations together, those 60y's are going to cancel, and then I'm left with, let's see here, this is negative 27x on the left side, and on the right side of the equation, this adds up to 81. Dividing both sides by 27, we get x equals negative 3, and now I can plug negative 3 back in for x, and I'll just do that over in this equation here, and that'll help me solve for the y value. So I have 12 times negative 3, which is going to be negative 36. And if I add that to the other side of the equation, that gives me 40 on the right side. So 10y equals 40, divide by 10, we get y equals 4. So then my answer, I've got negative 3, comma 4 for my point. For this one, I'm trying to solve this system of equations with the elimination method. First thing I need to do, because ultimately I'm going to be adding equations together, I need to make sure both equations are in the standard form, ax plus by equals c form. This first equation is not. I have to add the 3y to the left side to put it in that form. So that's my very first step, is to just rearrange that equation a little bit. The second equation is good. We have ax plus by equals c. And next thing I have to ask is, if I add these equations together the way they are, will anything cancel out? And it doesn't look like it will. The x's are going to give me 12x. For the y's, I'm going to end up with negative 9y, so that's no good. So is there something I could multiply one of these equations by to quickly get opposite-like terms? So there's two ways you could go on this. If you wanted to get rid of the x's, you could multiply this second equation here by negative 3. That would give us negative 9x, which would cancel with the positive 9x here. Or if you wanted to get rid of the y's, you could multiply this first equation that we rearranged by 4. That would give you 12y, which would cancel with the negative 12y. So really it's a difference of, do you want to multiply this equation by negative 3 or this equation by positive 4? Just kind of pick a direction and go with it. I'm going to multiply this equation by 4, just because then I'm not multiplying by a negative number, so I feel like I'm less likely to make a mistake doing it this way. So this ends up giving me 36x plus 12y equals 24. And then adding these two equations together now, this is going to be, let's see, the y's are going to cancel, so that was kind of the whole point of this. And now we've got 39x on the left side. And on the right side, let's see here, this is going to be 117. And this is the toughest part now, dividing both sides by 39. That ends up giving you 3, because 3 times 30 is 90, 3 times 9 is 27. 30 and 27 adds up to 117 if you're not using a calculator. So we end up then with x equals 3. And plugging that back in, I'll just do that over here. We've got 9 times 3 plus 3y equals 6. Now I can go ahead and solve for y. So that's 27 plus 3y equals 6. Subtract 27 from 6, we've got negative 21 on the right side. And then dividing by 3, we have y equals negative 7. So then my answer, we've got 3 comma negative 7.